In this section, we're working on the AI system in enemy tank, and we're going to review the two states, patrol and aiming. Our plan is to set up the enemy tank AI like this. When the player enters the lock range in the enemy, we switch to the aiming state, and when the player exits this range, we go back to patrol, exactly like what you see here. Select the enemy tank object, create a new script called enemy unit tank and add it. Then open it in Visual Studio. In this script, we want to work on the tank AI system, so we delete these lines and we define a few new fields in this class. First, we define the locking system accessor. Then we define the tank field. We also have the move speed and turn speed fields. These are related to the player's movements. The layer mask ray distance and ray point fields, just like in the player controller, are used in the raycast method to detect the slope of the ground. Next, we define the move input value and turn input value fields. We also define variables of the raycast info struct called raycast info and raycast info temp, which will be created later. The random index variable is used to choose a random point for the tank in the AI system. We also define the delay time ray and current time ray fields for the timer created for raycasting. We go to the player controller script and add the other required fields. Copy this line and paste it into enemy unit tank. For the Photon view, press Alt and Enter to add the needed namespace. Next, we define the waypoints field, which is a list of transforms. In the awake method from Unity, we reference the Photon view variable. Then we go back to player controller and copy these lines of code into enemy unit tank. In the next line after the if statement, we check if the if detected object property is true. If it is, we set move input value and turn input value to 0 and stop the tank's movement. Otherwise, these variables are set to 1 and the AI system drives the tank using the patrol method. To create the raycast info struct and the other methods, we can use the player controller script as a reference. So we go to player controller and copy these methods into enemy unit tank. And in the same way, we copy the detect ground specs method and the raycast info struct. The only method left is patrol. In this function, we first check that the waypoints list is not empty. If it is, we subtract the enemy's position from the random point's position. The resulting vector is stored in the target dir variable. In this if statement, the magnitude of the target dir vector is calculated and compared with 2. If the condition is not met, in the else if block, we first check if the random index is less than the length of the waypoints list. If it is, we add 1 to random index, otherwise random index is set to 0. One important point to understand here is that you should avoid using the magnitude property in calculations that don't need high precision. Like in our case, this is because magnitude is costly and can slightly affect game performance. It's better to use skewer magnitude instead, which is much cheaper. So here we replace magnitude with skewer magnitude. Next, if the distance is greater than 2 units, we first rotate the enemy tank forward direction towards target there, using rotate towards. The resulting vector is stored in new there. Then we convert the new dir vector to a rotation using lock rotation and assign it to transform that rotation. Save the script and go back to Unity. Here we create an empty object called roadway points. Then we add a sphere object. We don't need the sphere collider and the subject, so we remove that component. Select the sphere and duplicate it a few times. These spheres will be our waypoints, so we place each of them in different parts of the scene. Next, just like player spawn points, we create a new script called enemy roadway points and add it to this object. We rename the subject to enemy roadway points. Then double-click the script to open it in Visual Studio. Here, we create a public static instance of this class to make it easier to access its public methods using a singleton. We also create and declare the waypoints field as a list of transforms. In the awake method from Unity, we set instance to this class, and in the start method, we use a for each loop. First, we add all the waypoints to the waypoints list, and then immediately after that, we disable the mesh renderer component for each item. In Enemy Unit Tanch, we define a new coroutine called Fill Waypoints coroutine. In this coroutine, we set the waypoints variable to the getWaypoints method from the enemy roadwaypoints class and populate this list. Then, according to the random index obtained from this list, we assign a value to the random index variable. And in the start method, we call this coroutine. Now, to make this script network ready, we check if it's running on the master client. If it's not, we prevent the following lines from executing. We go back to Unity and assign the fields defined in this script. Now we go to the scenes folder and open sample scene, then we play the game. It seems we're getting null reference exception related to the enemy unit tank script on line 54. So we click this link and open the script and check it. Yes, here we forgot to assign the locking system variable. So in which, since enemy locking system is attached to the detector, we use getComponent in children to assign the reference. Save the script, go back to Unity and run the game. The enemy unit tank script is working correctly. When it sees the player, it stops and aims toward the player. And when the player moves out of the detection radius, it switches back to patrol mode and continues moving. Stop the game and go back to scene 1. Then we move sphere 1 to a better position and we do the same for sphere 2. Select the enemy turret object, create a new script called enemy unit turret and add it. Then open it in Visual Studio. For this script, we also go to enemy unit tank and copy some lines to use here. We copy this if statement from here and paste it in here as well. Finally, save the script and go back to Unity.